There are many things about LLMs which can make your life difficult when you take your project from pilot to production. If you don't want to get lot of beating from your bosses, watch this video till end guys, because LLMs are not deterministic in nature, but your bosses and your stakeholders will expect deterministic output from your generative AI application. First of all guys, let's try to understand what is the problem with all these LLMs. Okay, so I will ask a simple thing here. I have a query here. Okay, what is America and Venezuela issue in 2 lines, and let's see what ChatGPT is saying. So this is a recent issue going on between America and Venezuela. So it is saying something like United States and Venezuela clash mainly over something something. Okay, and let's ask this one more time. So you will see that there will be slight difference between the output. So the United States and Venezuela, the United States opposes Venezuela. So first line only there is some difference. Now this is called non-deterministic output. What is this called? Non-deterministic output, meaning the LLM will not give you same output every time you fire the same query. This is the problem when you build any generative AI production grade application. What is the problem? You cannot afford to have non-deterministic outputs for your critical business scenarios. For example, suppose a customer comes and tell you, issue me the refund, my product was bad, something like this. Okay, and then you have a LLM system in place that does something. You want a consistent output for this. You cannot mess up with the output, right? So let me try to explain you what will happen if you give a consistent output or if you give a non-consistent output, and how do we take care of that. So first of all I will say why LLMs fail in production and how can you avoid this failure. And we will understand with the example of two different systems that we will design now. So first system we will design is, let's say we will call that system A, and second system we will design, we will call that system B, right? First system that we will design, we will call it uncontrolled system. So what is the meaning of uncontrolled system is, the meaning is LLM is doing everything here, the very simple meaning. And here we will say governed system. Governed system means we as a practitioner, AI practitioner, we still use LLM, but we decide how our outputs will be generated. Now let me give you a flow of how things will be in uncontrolled system. First of all, there will be an input. So user will come, user will ask a input. Input goes to the LLM. Okay, LLM, and LLM takes the action. So imagine a customer coming and asking for refund, and you pass that query to LLM. LLM processes that query and takes the action, and then you get the result. This is an uncontrolled scenario, right? There are problems with this scenario. Now I told you about non-deterministic nature of LLM, right? So imagine this is a bot which is working for customer queries. Then what kind of problems you can have? First problem that you can have here is no control on what output, what your system will do. This is the very first problem, no execution control. Okay. Second problem is how it will give the output. That also you cannot derive or you cannot know, right? So I will say non-deterministic. Non-deterministic. These two are little different. Okay. Deterministic. Third problem that you will face here is it is dependent on basically history. So because it is uncontrolled, so if you give some history, right, history in the chat or history of your previous conversations, it will depend on that, history dependent, because you have left everything to the LLM. So this is a problem. I'll explain you with the code now, don't worry. And then there is no tracing of what is happening. Normally if LLM is doing everything, we don't have tracing of what is happening. These are some of the problems with your uncontrolled system. Now what is the way out? The way out is we will build a system which is called as EDCA style system. Now, if you work in generative AI, you must know this style of system, and what it does is it will also take a input, okay, it will also use a LLM, but pay attention here guys, LLM will be used only for reasoning. This is critical. LLM will be used only for reasoning, and then what will happen is you will have a layer of validation. Remember this, you will have a layer of validation. Validation means whatever LLM is giving me, I will first of all validate that, and validation will also happen in different formats. For example, I will fix a JSON and I will ask LLM to give me output in that fixed format only. Once the validation happens and I am happy with the validation, then only I will do the execution, okay, and once execution happens, then only I will give the result. So this is important. In that previous model, right, you directly jumped from LLM to result. Here you are adding few steps in between, and in between all these, right, one more step you are adding, and that step is nothing but logging or tracing. Logging or tracing, which can clearly tell you that what is happening in your system. Is there issue in the validation? Is there issue in the execution? Is there issue with producing the result? And this entire framework that I explained you now, which we will use in system B, is known as EDCA style. E stands for execution, okay, then we say decision, execution, decision, control, and audit. So we call it EDCA framework, EDCA, okay. So this line is just to make you understand, but these are various parts of EDCA framework. Now you might be thinking, if I put the same LLM on both, for example, if I put GPT-4o Mini here, GPT-4o Mini, and I put GPT-4o Mini here as well, then also do I need to do these things? Yes, of course you need to do these things, and the reason is you want to have a better control on the system, and you want a deterministic output. Most important in critical business scenarios, you want deterministic output. You want your output to be independent of historical chats. You want tracing, you want logging, you want monitoring, and then you want a proper validation. So let me try to show you how I have built the entire project in Git. You can obviously do a Git clone and run it yourself, okay. So I will go to Git and start explaining you. If you see here guys, in Unfold Data Science, I have a project here, why LLMs fail in production. Of course, for making my project beautiful and for writing all these, I have taken help of AI. That's not a problem, but concept and everything remains the same that I originally thought. All those things I am just giving you as it is, okay. So this is my own learning by implementing projects on the ground, guys. Why LLM system fail in production? It's not the model, very simple, okay. This project, what it does, it will tell you LLM system failures in production are caused by system design flaws, not the model itself, which I told you. Like if you use same models, right, then also your system is not going to perform nicely. System A will be uncontrolled LLM system, like I told you. System B will be governed LLM system, EDCA style. LLM provides reasoning only, deterministic execution layer handles action, okay. Whatever I told you, execution layer is not there in uncontrolled, non-deterministic behavior, history dependency, no audit trail, and unclear failure mode. This is also one thing, okay. So failure modes are not very clear. If it's a governed system, separation of concerns, deterministic output, structured output, full audit trail, clear failure modes. How EDCA style execution control works? As I told you, reasoning layer will be there, LLM, then validation, then execution, then audit. You can see here reasoning, validation, execution, results, and audit. So let me walk you through the files first of all. This is your uncontrolled system. What your uncontrolled system will do is, it will take a customer query. So see here, you are a refund approval system. Analyze customer refund requests and decide what action to take, okay. Available actions are approve refund, reject refund, escalate refund, request additional info. These 4 are the actions that my system can take, right? And how it will decide that which of these action it will take? So it will search for few keywords. So if you see here, in the reject indicators, it will search for these keywords. In the approve indicators, it will search for these keywords. If it finds these keywords, see, has reject any, has approve any, okay? If has reject, return reject. If has approve, return approved. If escalate keyword is there, then escalate. If additional, then request info. So this is how my plain uncontrolled thing will work. Now we spoke about controlled system or governed system. So governed system will have two parts. One is execution engine and another one is governed system. So if you see governed system here, right, you will see that there are granular level of details. First of all, it is telling you have to return in a JSON format only, and if result is not in JSON format, then it will get rejected. That is the first layer of basically structuring the LLM output. So you are a reasoning component in governed approval system. Your role is only analyze, not suggest anything. Only analyze the request and provide structured reasoning, just the reasoning, okay? You must output a JSON object with this structure: action, okay, parameters, order ID, amount, reason, then reasoning, why did you say this, and then available actions. So same 4 actions, but we are asking the result in a particular JSON format, and we are asking just the reasoning. We are not asking to take action, okay? You cannot execute actions, you only provide structured reasoning, right? If you see GPT-4o Mini, and here also you will see GPT-4o Mini, same model. See GPT-4o Mini 0.7 temperature. Here also you will see GPT-4o Mini 0.7 temperature. Temperature is 0.3. You can change it and check it. Response format is equal to JSON, okay? And then structured output is what we are getting, the JSON object from the LLM, right? And actions, parameters, and reasoning we will get. And all these 3 things, right? All these 3 things we will pass to the execution engine. So what execution engine will do is, first of all, it will see we are saying these are the allowed actions, okay? It will check the format. See, validate action. So first of all, if action is not in allowed action, then it will say action is not in allowed action. This is one layer of security here, I mean the validation here, and execution engine will do that. Otherwise, action config it will take. For all the parameters, it will take one by one. There are some rules which it will apply here, so we are putting some control rules here. And then in this entire code, right, if you see, everything is taking that JSON object and processing it. See, if action is equal to approved, then it will take these things: order ID, order amount, all these things. If it is reject amount, it will take these. Action taken is equal to this, and same for all 4 scenarios. And then it will add in the audit entry. So what happened, how it happened, everything it will add in the audit, and then it will return the execution result. So what all things are happening here? If you see from the beginning, right, this is class execution engine. So in execution engine, we are defining different action outputs. We are defining audit entry, we are validating action, we are validating, we are executing the things here, okay? And then we are returning the result. 3 important files here. One is governed system, another is execution engine. These 2 are for B type architecture, and for A type architecture, uncontrolled system, okay? Requirement.txt, anyway the packages you will need. Main.py is a gradual layer on top of it, and few important things to show you, right? So remember, you need .n file with OpenAI key, otherwise it will not run. Now let me go to readme.md, and how to run this. Obviously you need to create a virtual environment. I have done that already. So let me open my cursor. My environment name is vnLLM. So I have done that, and I have activated also and install packages also. You can do it from the beginning, but let me run this main file, okay? And it will open a nice Gradio UI, and I'll show you what is meant by controlled and uncontrolled output. So see here, side by side comparison. And what we will do is, here are some sample queries as well. First of all, we will just go here and we will write this one. Customer wants refund of 250 reason defective product. So let's see what happens for both controlled and uncontrolled. So both the outputs we will be able to see. Yeah, uncontrolled, I will approve the refund for order this. Reason, the customer has reported that product is defective, which typically qualifies for refund order. And uncontrolled is also approving and controlled is also approving, which is fine. Uncontrolled is saying approve refund, governed is saying approve refund 1 2 3 4 5. Uncontrolled system approve refund, this is unstable. LLM directly decides and executes. This is approved, this is stable. LLM provides reasoning. Execution engine validate and executed. Refund approved. Key differences, this is what we already discussed. Unstable, stable. And here you can see in the governed section we have all the trace of what is happening. In uncontrolled we don't have any audit log. Now one possibility is, if I rerun the query one more time, the possibility is the LLM might reject this as well. I mean the refund request. There is the possibility, it can happen. But here I did it again and it is still approving. So let's try another query. Customer wants a refund of 1 2 3 4 5, and you know what, I have given a threshold of $1,000 actually, and here we are asking $1,500. So let's see what happens. So what should happen is, I'm asking for a refund of 1,500. Both are escalating. The reason being 1,500 is more than 1,000. You see here the refund request for order 1,500, which exceeds the maximum limit 1,000 for a standard refund. Therefore this request must be escalated, and here also it's escalating, but I don't think it's comparing. The customer is requesting a refund significant amount 1,500. Okay, it's not saying that it is more than 1,000, because in a governed system we have put a 1,000 cap. Okay, we have put a 1,000 cap. If you see, if you'll go through the code, right, you will see that we have put a, if anything is more than 1,000, right, it will say that I will escalate this. See, max amount 1,000. Okay, so if it's escalate refunds more than thousands, right, it will say that I will I cannot approve anything more than 1,000. It will not be able to approve. Okay, so that is how our main engine is running. And if we go to, if I go and press one more time, right, I just want you to see that system behaves abruptly and differently for different inputs. The uncontrolled system, substantial amount. So it is saying I will escalate for 1,500, but there is a good possibility that it will not behave nicely, it will not behave consistently. Anyway, its output is differing. Okay, but our controlled output is always same. It will say that it's more than 1,000, so I will simply not accept the refund. And now the last one also we will run once. Let's see what happens here. Scenario 3, invalid reason. Customer wants refund for this one, reason changed mind. So this reason is invalid reason. So let's see what happens now. Okay, I will reject the refund and request. The customer is requesting for a refund due to change of mind. The reason provided for refund is change of mind, which typically falls under policy violation. As you can see, the response itself is very good, very consistent. And I am running one more time and you will see that at least the answer, the reasoning itself will change for the LLM. The customer is requesting a refund because they changed their mind, which is generally not covered under standard refund policies. Refunds for a change of mind are typically not approved unless there is specific body. So something it's saying which is not very convincing, but here it is very confidently refunding and it is telling the reason for refund. As usual, we have reasons here, we have our tracing, our way of how the system is performing, and that is how controlled and governed systems are working differently. So I hope you got an idea about these two architectures, guys, and you will always go with the EDCA kind of architecture. Otherwise you are not going to get deterministic output in your generative AI. Give me a thumbs up guys if you like this kind of content. I will mostly create content around production deployments only. So if you want me to continue these kind of playlists, just drop a comment and I'll keep doing that.